Alright, let's talk about product of two vectors. How do you multiply two vectors, right? There is actually two ways that will serve two different purposes. One is known as dot product, right? It is quite simple for us to actually multiply it. So this is how you do it. When you have two vector and they want you to conduct a dot product, what we do is we just multiply each of the component individually and sum of all of them. So at the end, you can expect that when conducting a dot product, we are going to have a scalar or just one value. Okay, so basically this is how you conduct dot product. So we have A times B, A1 times B1 plus A2 times B2 plus A3 times B3. Okay, this is how you do it, and you'll get one value as a result of a dot product. Okay, let's try to do one exercise. Okay, let's try to look at exercise 3.7 number 1. So this is the question. They want us to conduct a dot product and together with scalar multiplication and subtraction, if you can look at here. So we have A and B as a vector. So we are going to multiply 3 with A, which is this one, that will give us a new vector. So we have 3 times 2, which is 6, and then 3 times -3, which is -9, and then 3 times 1, 3, and then okay, sorry, so this is, I'm going to do it like this, dot with B, right, this one. Okay, minus with, we have A, which is this one. Okay, times with 2B, right, 2B, which is 2 times -2, so -4, right, and then 2 times 0, 0, and 2 times 3, 6, 0 and 6. Okay. So let's apply a dot product for these two. So we have okay, so this is how we conduct a dot product, as you can see here. Right, when conducting a dot product for these two vector, so 6 times -2 plus -9 times 0 plus 3 times 3, and the same goes for this side. So 6 times 2, we get -12, is 0, and then so plus with 0 plus with 9, right, minus with -8 plus 0 plus 6, right, so we have here -12 plus 9, 3, minus, sorry, -3, minus -8 plus 6, which is -2. So this will give us -1. negative 1. Okay, so this is how you do it. So in the next video we're going to discuss on how to conduct a dot product, okay, in finding the angle. Okay.